Next up in our transformations are reflections. And reflections, another word for the reflection is a flip. It has flipped it either across the x or the y axis. Now, if we have negative f of x, that causes a reflection across the x-axis, whereas f of negative x gives us a reflection or flip across the y-axis. Now, in these two examples we're looking at here, our parent function is a reciprocal function, which we see over here on the graph on the left right here. And if you notice, we've got what is called an asymptote running along the horizontal axis. In other words, it gets very, very close to the horizontal axis, but it never quite crosses it. And we also see one along the vertical axis as well. And you also notice that in our parent function, we see the graph in both the first and the third quadrants. Now, we're asked to write an equation for this transformation, which is a reflection, because I can see that we've moved from a first and third to what might be more applicable to a second quadrant and fourth quadrant. And then I also see that we have moved down. We've seen a vertical shift down from the horizontal axis by 2. So if I'm going to then write this equation for g of x, I'd say that g of x is equal to negative 1 over x, well, that's pretty sloppy looking, 1 over x minus 2 to not only give me the reflection, but also the translation or the vertical shift down by 2. Shall we look at one other? Shall we? Yes, we shall. So once again, I've got the parent function over here on the left. You can see it's occupying the first and the third quadrant. Now I'm more aligned with the second and the fourth quadrant. I do still have the asymptote here along the horizontal axis, so I don't have any vertical shift associated with this, but I do have a horizontal shift. Let's see. Where's the vertical axis on this thing? Right there, 0, 0, 1, 2, 3, 4. I've got a shift here, a horizontal shift by 4 units. Now, the denominator of a reciprocal function or a rational function is actually a grouping. So I can characterize this again as g of x. G of x then is going to equal negative 1 over x. I shifted to the left, so this is going to be x plus 4, because this actually serves as a grouping symbol, which gives me the horizontal shift of 4 to the left. Again, that's a little bit counterintuitive. Since it's a positive, you might think it's going to move to the right of the origin, but in fact it actually moves to the left. So hey, we've written some equations for some transformations. This time we used the parent function of the reciprocal function 1 over x. We had both a reflection, and our first one we had a vertical shift, our second one we had a horizontal shift.